Hello everyone, I am Riya Malani, a IIT Roorkee student. Today I'll be discussing about how to check if a number is a power of 2 or not using 8085 microprocessor. So here's the overview of my presentation. So first we'll be discussing the problem statement in detail. Then I'll be going through the approach that I have used to solve the problem, then the process flow and the flow chart, and then I'll be showing you the code and also a small demo of the code and the results. So let's begin our presentation. So our problem is to check whether the given 8-bit number is the power of 2 or not. So how do we define if a number is the power of 2? So if it can be written in the form 2 raised to power x, where x is a whole number, then we say that it is a power of 2. So for example, 32 and 1 are power of 2 and 20 or 18 are not. So the key observation here is that if we write a number in binary representation, so if all the bits except one bit is zero, like all other bits are zero except one bit, then we can say that the number is a power of 2 and the sum of the bits will always be 1 in that case. So for example, 32, 1 and 128, their binary representation shows that only one of the bits is 1 and others is 0. So this is the key observation that we are going to use. Now there are other two main concepts, one of which is masking that I'll be using. So what is masking? So masking is basically ANDing two numbers, like performing AND operations between two numbers. So we can extract one particular bit of our choice by using this approach. So for our case, if we want to extract the least significant bit, what we can do is we can AND the given number with the number 1 and we'll know for sure that what our least significant bit was. So for example, this is a number and this we want to know what the least significant bit is. So we can AND this number with 1 and this will be our result. So by looking at the result, we can say that the least significant bit was 1 in the original number. And if it were 0, then here it would be 0 and similarly we would be able to tell what is the least significant bit. Now another main concept is now we have a least significant bit, but we want all the bits, we want to read all the bits. So what we can do is we can rotate the accumulator content and extract each bit one by one. So for rotating the accumulator content, the command we use is RRC. So how it works is it copies the least significant bit into the carry flag and also to the most significant bit position and shifts all other bits towards right by one position. So our number would be shifted like this. Now an example of rotation is shown here. So before rotation our number was like this. Now after rotation this 0 will get copied to this position and 1 will get copied to this position and all other numbers will move towards right. Similarly, after another rotation, this would be rotated and we would get this number. So one main point here is that this can only be performed by copying the number onto the accumulator. So now our problem comes down to three steps. First step is to initialize the register with the 8-bit number, another number with the loop counter because we want to run our loop for 8 times, and another for storing the sum of bits that we are going to calculate. Now we start the program by moving the 8-bit number to the accumulator because we can perform the operations using the accumulator only. Now our second step would be to extract the least significant bit and store the result whether that is 1 or 0. If it is 1, we will add it to our sum counter, otherwise we would skip that step and then we would rotate the number and and repeat this process 8 times for each bit and finally store the sum. Now, to check whether the sum is 1 or some other value, we would initialize the accumulator register with the value 1 and we would compare it with the stored sum value. So now if the sum is 1, so as discussed earlier, we for sure can say that the number was a power of 2, else it was not. So we'll store the result and we'll terminate the program. So now here's the flow chart of the process. So after starting the program, we'll initialize all the required registers. Then we'll perform the end operation with 1. Now, if the accumulator content becomes 0, that means that the least significant bit was 0 and we do not want to increment our sum value. So we'll directly move on to the next step. If it was not 0, we would increment the sum counter. So our next step is to move the content of D to A, then rotate the accumulator content and then update the D value again. And then decrement the loop counter as we have performed one operation. Now we'll check if the loop counter is 0 or not. If it is not 0, we'll repeat this process. If it is 0, then we'll continue with our algorithm. Now after the loop has run for 8 times, we'll initialize, we now have our sum value, that is our sum of bits. Now we'll initialize our A register with 1 and compare it with the sum value. So if A is equals to C, that is the sum is equals to 1. If it is equals to 1, then we'll store 1 at the memory location and that means that our number is a power of 2 and we'll terminate the program. If it is not, then we'll store 0 at a memory location and we'll terminate the program. So this is all about the approach and the flow chart. Now here's the code of how to implement the same. So here we are initializing, storing our 8-bit number into the D register. Then we'll initialize the B register with 8 because we want to run our loop we want our loop to run for 8 times. Then we'll initialize the sum value with 0 and we'll move the D content to A so that we can perform operations onto it. Then we'll perform the AND operation using A and I command, which is AND immediately with a data, that is the data given is 0 1 H in this case. Now as discussed earlier, if it is 0, then we'll skip to the next step. If it is not 0, then we'll increment the sum counter. Now we'll move the content of D to A, then we'll rotate the content and we'll again update the D value and then we'll decrement the loop counter and we will keep on repeating this process for 8 times. Now this is the code for comparing the number with 1. So C stores our sum of bits and A stores 1. So if they are equal, then some 1 would be stored at the memory location 2000H, otherwise 0 would be stored at the memory location 2000H. So now here's a short video that I made from the code that I've written. So as we can see, I have initialized given the 8-bit number as 0 1 initially, which is 1 in decimal, and we can see that the output is 1. That means our number was a power of 2. Again, we are giving another input, that is 20. 20 in decimal is equivalent to 32. So it should give 1. And 21, for 21 it should give 0, and as expected it is giving 0. So our code is working properly. So as for our approach, we can say that this can be used in, like, this is the thing that is used in many problems as a sub problem, that is we want to find whether a number is a power of 2 or not. So this could be one of the ways to do that. And also while solving this, we were counting how many bits of the number were 1 or 0. So that could also be useful in some cases. So that is it for the presentation. Thank you.